Okay, let's see. So last week we had created this project, the SP 4500 SP19 Section 3 JGA, and we had created a couple of things here. We had created a model where that represented a simple hello world, and also a user that had a couple of information there, such as username, password. So this is a data modeling a user of the system. We had also created controllers that was able to expose certain data on the web, right? So this technique is a very important technique that you should be familiar with, of being able to expose data and behavior on some network, right? That you can access it by knowing its IP address and its location in a network, in a wide area network. So this making available data and behavior is part of the concept of web services, right? Of being able to provide some kind of service, either data or behavior, exposed through the web. So web services. So I have a presentation that I'd like you to take a look at, and it's available in this week, called Web Services. So web services, as I mentioned, is a concept of making data and services available on the web. And to do that, we had created Spring Boot. Most frameworks provide a means of creating web services. Spring Boot, just like any other framework, has its own little quirks on how to do that. And last week we created a simple application, and we exposed a simple hello world, right? Where we were able to just have a little hello world service. Yes? And this was also part of the assignment for assignment number 1. All right? So I'd like to expand on that concept. All right? Since this it's bigger than just exposing data. Right? So first of all, I'd like to say that we are using HTTP as the protocol for exposing this data. Yes, and that's only because of historical decisions that were made along the last couple of decades. Right? With the advent of the internet and the World Wide Web, it became very, very cheap and very easily to be able to put up processes running on that were able to communicate with one another using just the HTTP protocol. It used to be that before HTTP, before the web, any two machines that wanted to communicate, you had to go through quite a bit of administrative red tape, right, to open up a particular port, open up a particular IP address, and have two machines talking to one another. Yes, but ever since the World Wide Web took off in the 90s, setting up a server, an HTTP server, was just trivial. Right? There was a dime a dozen. Right? There were lots of open source solutions, and everybody had a web server. And also the browser became so ubiquitous as another process that could talk to over a network. So HTTP became kind of like the de facto way of sharing data amongst disparate systems. Yes, this technique allows you to just do just that. Have two processes talking to one another, talking across HTTP. Originally, HTTP was only meant for displaying some web pages, right? When Tim Berners-Lee came up with the World Wide Web, his intention was to share research results with his colleagues. But ever since then, it has evolved into its own thing. Something that nobody would have predicted back then, right? Today is the backbone of a lot of processes, interacting data across HTTP. So Spring Boot that we introduced last week allows us to make it very, very easy and share data across this new infrastructure. Okay, last week we we implemented this hello world. But let's take that a little further. Let's take that a little further. Okay. So for instance, we did talk about being able to implement exposing not just these dummy hello strings, but exposing real data like a user, right? User data, right? So let's expand on that idea. Let's expand on that idea. This data might be represented in records in some database, right? Instances of this user object might be actually stored in some row in some table, right? And we would need to be able to map that somehow. We'll talk about that a little later. Okay, let's talk on this side of the equation. Now that we have an instance of some user, I would like to be able to make it available on the web. Okay, so let's do that. So for instance, one of the things that we might do is create here under controllers, or even better, in its own package. All right. The package, we'll call it services. All right, we'll create a class called user service. So under here, we're going to put all the services, all the operations that we would want to do about users. So user is a data type, and typically there are only a few operations that we want to do with any data type. Right? We would like to be able to create the data type. We'd like to be able to update that data type. We'd like to be able to retrieve that data type, or we are to be able to remove a particular instance. Yes? All right? So a user service is exactly what we want. A service allows you to encapsulate all those behaviors, right, and expose data resulting from those behaviors. Right? So let's put that in there. So in here, in this user service, you would have all the operations on that particular piece of data, which is users. So anything that happens to users would go through this one service, right? So what could we do? We could do maybe return a list of users. So this is find all users, and this would return an array of users, or it might be a find a particular user. So find a user by an ID if you give me an integer ID, or I might have maybe a find a user by username. So if you give me a username, I might retrieve that user from by the username. I might also be able to create a brand new user, right? So I might be able to create user. If you give me a user instance, I might be able to write that to a database, right? And then retrieve and then return to you the record that I just wrote to a database. I might be able, I probably might want to remove a database, right? So delete user. If you give me their ID integer, I might be able to remove that user from a data set of users. Yes. Plus, I might be able to modify an existing user. So I might have update a user, and I might give you the ID of the user I want to modify, and maybe a new version of that user, having modified all sorts of things. Yes? Make sense? So all CRUD operations, create, read, update, delete operations, would live in this one service. Okay? Which would give me access to modifying anything that I need about that particular type of data. Right? And this hopefully would be backed by some data mapping to some rows, to some table in the database. Yes? We'll talk about that a little later. All right, so let's just look at one of these. All right, let's look at just one of these. So for instance, let's see, find all users. Let's implement that, and maybe implement here a couple of these. So let's create maybe Alice. And this might be new user, and this would be maybe Alice. Maybe I give the ID Alice, and then have maybe Alice, and then Wonderland. It's that user. I might not have that constructor, but I'll add that constructor. So create a constructor. There it is. And in the constructor, I'll have something like this dot ID. I don't have ID. Oh, I don't have ID. I'll create it. And then we have this dot username is the first string. Maybe username. And this dot first name is equal to first name. So this is probably first name. Oops. And then this dot last name is equal to last name. So this might be last name. And I don't have ID, so let me add ID. Create field ID. There it is. I'll say it's an integer. And create a setter and getter for this. So let's see setter and getter. And add it to the end. There it is. Because I have this argument constructor that takes arguments, I lost the default constructor, so I'm just going to create it again here. There we go. All right, so excellent. So we have the user. So now I can instantiate Alice. Let's instantiate a couple more. So let's instantiate here Bob. So this would be Bob with a different ID, and this would be maybe Bob Marley. And maybe I can create an array of users. So users. This would be maybe an array of Alice and Bob. So this final user, probably having retrieved the data from some database, can return the users. Okay? All right. So this is just a plain old Java object. There's nothing special about this. Other than I can now expose this on the database on the web, right? Make it available as a web service, right? By making this a REST controller, which we looked at last week, and then mapping this particular function, so this method, so I can expose it and run it from outside, right? By mapping it to a URL that can execute this, right? So this I can map it to a GET request. So remember, HTTP has all sorts of types of requests, get, put, post, delete, right? There's a whole bunch of them. The simplest one is the GET request. That's the request that all browsers do when you go to any website, right? You type the URL. What the browser is doing is generating a GET request, right? So this is going to be answering to a GET request that somebody's going to come in, and that's going to have the following URL mapping, right? So if it ends with /API/user, we're going to return all the users. Okay, so let's try that. Let's see if this blows up. Let's see the demo application. Let's run this and save it. Yes. Runs maybe. Okay, so let's try and hit this. So it'll be localhost 8080. It'll be API and user. And indeed it comes back, right? We see we have Alice, we have Bob. And notice that this is a format of data, right? This is not meant for rendering. It's not meant for a web page. It's not meant, this is data that two processes can use, right, to exchange data, get me data, send me data, retrieve data, change this data, remove this data. Yes? And so this allows multi-processes to interact with one another. So what's the deal with web services? So web services imposes certain structures on this idea of exposing data and behavior. Right? It tries to create a language around this very important capability. Right? For instance, one of the things that it imposes is that this URL shouldn't be just anything. I mean, this could be anything. Right? I could say, this could be anything. If it could be anything, what should it be? Right? What should it be? So one of the things that the web services style of programming imposes certain restrictions on what this should be. So one of the things that it should be is that this should be based on whatever the data that you're asking for. If you're asking for users, this should be called users. If you're asking for courses, there should be courses, right? If you're asking for services, this should be a service. Yes? So that's one of the things that it imposes. The other thing that it imposes is that typically this data doesn't live all by itself. Usually data is related to other data, right? Maybe a faculty is teaching a course, right? Or maybe an author wrote a book. So there's always relationships between objects. Yes, right? So web services imposes relationships between objects. So for instance, if there were a different object here, maybe a book, right, where the book might have here private string title, and this and I finished modeling that, and this user wrote a particular book. They might have a whole array of books that they wrote. So now there's a relationship between a particular user having written these books and this other user having written those other books. Yes? So now there's a relationship between them. Make sense? Right? So for instance, to be able to retrieve books from a particular user, we should be able to do certain things like this. For instance, I would like to be able to say public book. Maybe I want to retrieve all the books. Find all books for user, right? And if you give me the integer ID of the user, I can go and fetch you all the books that particular user wrote. Make sense? Right? So here, whatever algorithm I have here that does that, right? Perhaps a query to a database. What web services impose is that this URL, whatever URL I use here, should capture the fact that these things are related to one another. That users are related to books and books are related to users. Yes? Right? So for instance, one of the things that it imposes is that the URL should have the following pattern. Right? It's the user. You have to tell me a specific user. Right? And then you can tell me what books are for that particular user. Because depending on what ID you give me, I'm going to give you a different set of books. Yes? If it's this author, I'll give you these books. If it's some other author, I'll give you some other books. Yes?
Yeah, this is actually a question I was thinking about. If you think about Facebook as an example,
yep.
Like they have swaths of information tied to an individual user, say like your groups,
yep.
pages, likes, all this, that you would argue don't exactly fit with the response for just the user because it's so much information.
Yes.
How exactly do you break it apart? Because I know there's the general convention that you don't want to have too many nested routes in your URL. So
right.
What would that look like at scale?
Yeah. So typically that would be additional question here. What is it that you're asking for for the response, right? Based on a certain subset of data that you want. So for instance, in different summaries that you would ask for, as opposed to the entire data set, right? And you would ask for different representations of that data, right? That only has friends, or only has images, or only has certain subsets of that data. And also, this one is assuming that the data is a relational database, whereas Facebook might not be using a relational database, right? It might have instead very unstructured data, right? That use tags to relate certain clouds of pieces of information with other pieces of information that have no particular structure or no particular relationship like we have here. This would be specific for a relational database where you have a very clear one-to-many relationship or a very clear many-to-many relationship, that if you fix one end of the relationship, all the others are very well determined, right? And you have foreign keys or primary keys that allow you to navigate a hierarchical data structure. In those cases, it probably is not even hierarchical, right? Where you have all these disparate systems that you don't even know what the relationships are, that you have to data mine and identify those relationships after the facts, right? We're saying suggesting friends or suggesting products or suggesting things. And why is it suggesting me? It says I have never bought that, right? But because of some other similar aspects of some other users, perhaps these are related to me nevertheless, right? So yeah, so they're using very unstructured pieces of data and gathering all these things and building these disparate parts of the response, based on certain data mining that they've computed afterwards. Yeah. Yes.
So really what they do is they use GraphQL, which
Yeah.
is their own service they made, which allows you to basically say the structure of data you want in terms of like a user or something else in the node, and then based off of that, it'll give you whatever you need based
Right.
on that type of structure.
Yep.
Because it kind of falls apart when you're using a RESTful API.
Yeah. Yeah. Yeah.
So they have their own
Right.
day-to-day open source systems.
Yep. Outside, you had a question?
Yeah, a quick one. You use the term enforce when you're talking about how this subservice that we're creating
Yeah.
enforce this kind of restriction.
Well, it's a style. It's a style.
Okay, it's a
Yeah. Yep. All right, gonna leave it here. Thank you.